Hello everybody, you are all welcome to my channel Chaitanya Academy. Today I am going to start second part of my video in which we will learn the properties of inverse trigonometric functions. Let the function f of x, let function f of x whose inverse is represented by the symbol f inverse x. Now I am going to define f inverse x. We have if f is mapping from A to B, where f is the function and A is the set, B is another set. A is the domain set over here, that is domain. B is the range set. It is a function which is bijective. Bijective means the function is both 1, 1 and on 2. The function is bijective if and only if the function is 1, 1 and on 2. Then the function, let me explain it. Then the function f inverse is mapping from B to A. F inverse is mapping from B to A exists such that f inverse of f x equals to x, or we can write f inverse of f of x equals to x. That is the concept of inverse function. Is it clear to all of you? Yes. Now applying this property on various types of trigonometric functions and their inverses. Our conclusion is f inverse of f of x equals to x for all x belongs to A. X belongs to A. Now applying this property, on various trigonometric functions and their inverses, we obtain the following. We obtain the followings. That is property 1. In property 1, we can have different sub-properties of inverse trigonometric functions. We can have 6 different functions. Number I, sine inverse of sine x. Sine inverse of sine x equals to x for all where x belongs to minus pi by 2. This value is the domain of the function. Minus pi by 2, domain of inverse function. Minus pi by 2, pi by 2. Next, number 2, cos inverse cos x equals to x for all x belongs to closed interval 0, pi. After that, I will explain other properties. Third one, tan inverse tan theta, tan x equals to x for all x belongs to minus pi by 2 open interval. Number 4, cot inverse of cot x equals to x for all x belongs to open interval 0, pi. Number 5th one, sec x equals to x for all x belongs to for all x belongs to zero comma pi minus pi by 2 minus pi by 2, because sec x equals to 1 by cos x. Sec x is undefined when the x value is pi by 2. So pi by 2 value is going to be excluded. Number 6. Cosec inverse cosec x equals to x for all x belongs to minus pi by 2 minus close interval minus pi by 2 minus 0. This is the first property of inverse trigonometric function. Then we will discuss second property regarding inverse trigonometric function. Is it clear to all of you? Let us start second property. Property 2. If the function f of x is mapping from a to b is bijective. If function f is mapping from a to b is bijective. Bijective means, I have already told you, the function is both on 1 and on 2. Then f inverse is mapping from b to a exists such that f of f inverse x equals to x or f of f inverse x equals to x for all x belongs to b. For all x belongs to b. Here b is the domain of f inverse x. In previous property, a was the domain of the function f. Now applying this concept in inverse trigonometric functions. Now applying this property on various trigonometric functions and their inverses. We obtain the following. We obtain the followings. We obtain the followings. See. After that, our main objective was in this property. Our main objective was in this property f of f inverse x, f of f inverse x equals to x. Therefore, the property 2 is also have 6 different or sub properties like bit I. Sine of sine inverse x, sine of sine inverse x equals to x, such that for all x belongs to closed interval minus 1 1. Number 2, cos of cos inverse x equals to x for all x belongs to same closed interval minus 1 1. Third one, tan of tan inverse x equals to x for all x belongs to R, the set of real numbers. Number 4th one, cot of cot inverse x equals to x such that for all x belongs to R. 5th one, sec of sec inverse x equals to x for all x belongs to R minus 1 1 open interval. 6th one, cosec of cosec inverse of x equals to x for all x belongs to R minus 1 1 open interval. This is the second property of inverse trigonometric functions. After that, we will discuss third property of inverse trigonometric functions. Please note it down. Let me erase it. Let me erase it first. Property 3. In property 3, we will discuss sin inverse 1 by x equals to cosec inverse x for all x belongs to r minus 1 1. Second one, cos inverse 1 by x equals to sec inverse x for all x belongs to r minus 1 open interval. Look at this. Third one, tan inverse 1 by x equals to cot inverse x for all x belongs to or x is greater than 0. X is greater than 0. Fourth one, same, tan inverse 1 by x, its suboption, that is minus pi plus cot inverse x, where x is less than 0. X is less than 0. These are all third properties. Please note it down. After that, we will discuss fourth property. Is it clear? These properties are applicable for solving different types of problems regarding inverse trigonometric functions. We will do the latter in the end of this video. Clear? Let me erase it. Then property 4. Property 4. Sin inverse subproperties. Sin inverse minus sin x equals to minus sin inverse x, where for all x belongs to minus 1 1 close interval. Number 2, cos inverse minus x equals to pi minus cos inverse x for all x belongs to minus 1 1. Number 3, tan inverse minus x equals to minus tan inverse x, where x belongs to the real number set. After that, we will start fourth subproperty. Cot inverse minus x equals to pi minus cot inverse x, where x belongs to the set real number. Fifth one, sec inverse of minus x, sec inverse of minus x equals to pi minus sec inverse x, where x belongs to r minus minus 1 1 open interval. Sixth one, cosec inverse minus x equals to minus cosec inverse x, where x belongs to r minus 1 1 open interval. That's all about fourth property. Is it clear to all of you? Please note it down. After that, we'll start fifth property of inverse trigonometric functions. Clear? Let me read it. Then property 5 or fifth property. Subproperty sin inverse x plus cos inverse x equals to pi by 2. Remember, sin inverse x plus cos inverse x equals to pi by 2. For all x belongs to minus 1 1 closed interval. Subproperty 2, sin inverse cos inverse. Next, property 2, tan inverse. Tan inverse x plus cot inverse x equals to pi by 2. That is, x belongs to r. After that, first one sin cos or sin inverse cos inverse. Second one tan inverse cot inverse. Third one sec inverse cosec inverse. Sec inverse x plus cosec inverse x equals to pi by 2. For all x belongs to r minus 1 1 close interval. That's all about fifth property. Please carry on. Please write it down. Is it clear to all of you? Next we will start sixth property of inverse trigonometric functions. Let me read it. Now, sixth property. Beta tan inverse x plus tan inverse y equals to tan inverse x plus y divided by 1 minus xy, where or for all xy is less than 1. And property 2, tan inverse x minus tan inverse y equals to tan inverse x minus y 1 plus xy, where for all xy is greater than minus 1. That's all about sixth property. Please note it down. Clear? Is it clear to all of you? Let us start seventh property of inverse trigonometric function. Let me erase it first. Seventh property. Beta I. 2 tan inverse x equals to sine inverse 2x by 1 plus x square, such that minus 1 is less than equals to x is less than equals to 1, or x belongs to closed interval minus 1 1 1. 2 tan inverse x equals to cos inverse 1 minus x square divided by 1 plus x square, where or for all x is greater than equals to 0. Third one, 2 tan inverse x equals to tan inverse 2x by 1 minus x square, where minus 1 less than x is less than 1. These are all properties of inverse trigonometric functions. Is it clear to all of you? Please note it down. These properties are most essential as per the CBSE or state board examination point of view. And these properties are also most essential for JEE, main and advanced. Let me read it. After that, let us work out some problems regarding inverse trigonometric functions. Question number 1. Question number 1. Evaluate tan inverse sine of minus pi by 2. That means we have to find the value of inverse function. The inverse function is tan inverse and sine minus pi by 2. Now applying the property, we have solution. Tan inverse sine of minus pi by 2 equals to tan inverse. First of all, we will work out regarding inner bracket. In the inner bracket is minus pi by 2. That means sine minus pi by 2. We have already known that sine minus theta equals to minus sine theta. That is equals to minus sine pi by 2. Since, write it down, since sine of minus theta equals to minus sin theta. After that is equals to tan inverse minus theta. We have already known that from the property tan inverse minus theta. Please look at your property. Tan inverse minus x equals to minus tan inverse x. Tan inverse minus sin pi by 2 equals to minus tan inverse sin pi by 2. Or you can write tan inverse minus sin pi by 2 equals to minus tan inverse sin pi by 2. This extra step may be omitted. Tan inverse minus sin pi by 2, tan inverse minus sin pi by 2 equals to minus tan inverse sin pi by 2, as since you can write tan inverse minus x equals to minus tan inverse x. This rule or this property can be applicable over here. Then that is equals to minus tan inverse sin pi by 2 value. Pi by 2 means 90 degree. The value of sin 90 degree equals to 1. Since sin pi by 2 equals to 1. After that, tan inverse 1 value means tan pi by 4. Tan pi by 4 is 1. We have tan pi by 4 equals to 1. That is equals to, from the property tan inverse tan theta equals to theta, or tan inverse tan x equals to x, that is pi by 4. Since property is tan inverse tan x equals to x, from this property the value will be pi by 4. This is the actual solution or value of tan inverse sin minus pi by 2. Therefore, we can write tan inverse sin minus pi by 2 equals to pi by 4. This is the required answer. Sorry, minus pi by 4. Sorry, minus over here, na? Minus pi by 4. Tan inverse sin minus pi by 2 equals to minus pi by 4. Is it clear? Please look at it. Next question. Question number 2. Evaluate cos inverse cos of 13 pi by 6. Solution. Cos of or cos inverse of cos 13 pi by 6. According to the property, the value will be 13 pi by 6, which is not correct answer. See the property cos inverse. See the property cos inverse cos theta or cos inverse cos x, where x value will be in between 0 to pi. 13 pi by 6 is not belonging to 0 to pi. That is why we have to reduce this value. Cos inverse cos 13 pi by 6 can be written as 2 pi plus pi by 6. 2 pi plus pi by 6. 2 pi plus pi by 6 means 2 pi plus theta is lying in the first quadrant of the coordinate plane. That's why we have already known that in the first quadrant of the coordinate plane, all trigonometric values are positive. So, cos inverse cos 2 pi plus pi by 6 can be written as cos pi by 6. You can write it down since cos 2 pi plus theta equals to cos theta. Similarly, according to the property of cos inverse x, cos inverse cos theta equals to pi by 6. That is equals to pi by 6. Since cos inverse of cos x equals to x, which is the required value. Pi by 6 is the required value or answer. In this way, we can work out other problems. Let us work out another problem over here. Please note it down. Let me erase it. Question number 3. Find the value of tan inverse. Find the value of tan inverse tan 9 pi by 8. Tan inverse tan x. The x belongs to minus pi by 2 open interval. In this case, 9 pi by 2 will not lie in between minus pi by 2 pi by 2. That is why we have to work out the problem. tan inverse tan 9 pi by 8 can be written as tan inverse tan pi plus pi by 8. That is equals to tan inverse tan pi plus pi by 8. That means tan pi plus theta. Pi plus theta will be in third quadrant. Pi plus theta will be in third quadrant of the Cartesian plane. In the third quadrant, tan function is positive. That's why we can write tan inverse tan pi by 8, since tan pi plus theta equals to tan theta. That is equals to pi by 8. That is equals to pi by 8. Since tan inverse tan x equals to x. The required value is pi by 8, which is the final answer. These are all about properties of inverse trigonometric functions, and other problems are there. In the next video, I will work out long question answers regarding inverse trigonometric functions. Thank you all.